Students, this will be the first video for Unit 2, Structure and Bonding lesson, okay? So, you should focus more on this unit, especially because this unit alone can carry a huge marks for your A-level paper, okay? So, we should pay a little bit more attention on this unit, okay? Okay. Now, basically, in this lesson, what's important is more than bonds between atoms, we pay attention to the structure of the compound, to the structure of the molecules. Why? Because the properties of a molecule or a structure, the properties of a molecule or a compound is determined by the structure, by the arrangement of the molecule. Not mainly by the bond, okay? So, by the arrangement, okay, more than the bond. So, to emphasize this point, I'll take one example, okay? Now you see, students, you can see diamond and graphite. Those two are allotropes of carbon, okay? Now carbon is an atom, okay? Now there are two allotropes of carbon. Basically there are three allotropes. You will study the third one in the 6th unit. So for now, just to explain this example, okay, there are two allotropic forms, graphite and diamond, okay. In both of these compounds, there are carbon. But the boiling point of diamond is extremely high than graphite. Why? Because the arrangement, now both of them has carbon, okay? Both of them have single bonded carbons between each other. But the arrangement is different. Therefore, the properties of the compound differs, okay? So what I'm trying to emphasize here is we mainly have to pay attention about the arrangement of the compounds. Okay. Now let's talk about. So okay, let's read. Now I have this tube. I'll drop the PDF on the Telegram. Okay. More than bonding, structural arrangement of substances determine the properties of substances. So that we mainly discuss about structural arrangement of substances and bonds. Carbon exists in graphite and diamond state. Both consist of carbon atoms and covalent bonds are present. So, in graphite, the arrangement is like this, okay? There are layers of carbon, like this, okay? It goes like this, it continues. Okay, it continues, and there's a similar layer like that below also. Okay, and between these layers there are some bonds. You'll learn about it later, okay? For now, just remember that this is the arrangement of graphite, okay? So if you take diamond, the arrangement is like this, okay? It goes on like that. So here, one carbon atom is bonded to three other carbon atoms. Here one carbon atom is bonded to 4 other carbon atoms. So the arrangement will determine the properties of substances. That's the point that I want to emphasize here. Okay. Bond is a force holding atoms or ions together. Atoms, okay. Now, okay, leave this aside. Now we are going to talk about bonds. Okay. Now refresh your minds. Let's start freshly. Bonds. Okay. What is this bond? Now, what is meant by a bond? Okay, what is meant by a bond? A bond is a force holding two atoms together. Okay. A bond is a force holding two atoms together. Why do we want a bond? Atoms alone cannot be stable. Okay, some atoms alone cannot be stable. Therefore, they form bonds with another atom so that they become stable. Okay, so that they become stable. Unstable. Now, if you're unstable, now let's say, why do we marry? We marry to become stable. So in nowadays it's the other way. Okay, like we marry and then unstable. But here, atoms form bonds because they want to become stable. So if they are not stable, that means the energy is high. And when high energy, they can, let's say, you have more energy, you are less stable. You have less energy, you are more stable. So what happens is what happens is atoms form molecules. Atoms by bonding form molecules. Okay, atoms by bonding form molecules. So why are we forming bonds? To become stable. That means this is less stable, molecules are more stable. High energy, low energy. So while I'm explaining this, what you have to do is you have to take a CR book and write this down. So high energy, low energy. From high energy, it has gone to low energy. That means energy has released. Okay. Therefore, bond forming reactions. Bond formation reactions are exothermic. Bond formation, this is just, you will learn about this detailed in 5th unit, but maybe in a term test they can ask for an MCQ. So just remember this. Now, high energy to low energy, energy is released, therefore exothermic. If bond formation is exothermic, then bond breaking is endothermic. Careful listen, bond breaking is endothermic. Okay. Take this note down. You can pause the video and write this down if you want. These structures as well. Okay. Bond formation is an exothermic process, so that is stabilization process. Therefore, bond formation makes the atoms to be stable thermodynamically as well as of electronic configuration too. So you can read those things. Let's go to the next topic. You can pause the video and take this note down. Okay. Okay, now the next thing that we are going to discuss is, now we are talking about bonds. Now we know what is meant by a bond and why bonds are formed. Okay, so the next topic is types of bonds. Carefully pay attention for this topic. Types of bonds. Now Lamai, bonds, I will divide this topic into two. Okay? The first one is primary bonds. Carefully listen, primary bonds. Second one is secondary bonds. Okay, this lesson is quite interesting because when you do questions, you know that you can easily score from this. Okay, so from the beginning itself, you pay attention to this lecture. Okay, pay attention to the explanation. Know the difference between the primary bonds, secondary bonds, and then I'll explain those again. Okay, like learn interestingly. Okay, learn interestingly more than taking it as a burden. I should pass it and I should pass it, and not like that. Okay, learning has to be done interestingly. Okay, learning has to be done interestingly. Okay, primary bonds. Now, what is meant by primary bonds and secondary bonds? Now, you might think, oh, primary bonds, secondary bonds. What is meant by primary bonds? Primary bonds, lamai, are the bonds that are present between two atoms. In between atoms, okay? Within the molecule, okay? Let's say a molecule H2. How is the H2 structure present? Like this. Okay? Primary bond is a bond present within the molecule. Now this is a molecule. This is a primary bond. Primary bond, now I have given the definition as well. Primary bonds are bonds that are present within the molecule. Then second, what is it called? Bonds present within the molecule are intramolecular interactions. Intramolecular interactions. Bonds present within the molecule. Okay. Another example I take for this is PCl5. PCl5. I wonder whether the mark is clear. Hopefully, yes. PCl5. PCl5. So this is a molecule. This is a molecule. So primary bond means the bond present between within the molecule. So this is a primary bond, this is a primary bond, this is a primary bond. Now what is meant by secondary bonds? Secondary bonds are bonds present in between molecules. This is within the molecule. Now secondary bonds are bonds present in between molecules. Okay. Now let's say this is a molecule H2O, water, and this is another H2O molecule. So secondary interactions are bonds that are present between two molecules. Okay, between two molecules. Okay, now you know the difference between primary bonds and secondary bonds. Now in this video we are going to mainly discuss about primary bonds. Okay, and actually this unit is mainly focused on this part. Okay, so this one you will learn at the end of the unit. For now, let's focus on the primary bonds. Okay, take this note down, and yeah, in the tute the note is given. You can take this down. See, this unit is a bit long unit, and since this is like for 2027 students, this is like new, we can't go quickly, right? So don't worry, we can finish this on time. The main thing is you have to get the idea. Okay, get the idea, get the theory. Okay. Primary bonds, secondary bonds. Okay, alright. Now, this primary bonds, I will divide this primary bonds topic into 3 subtopics. Covalent bonds, ionic bonds, metallic bonds. Okay, covalent bonds, ionic bonds, metallic bonds. Now this covalent bonds topic has 3 subtopics. Okay, has 3 subtopics. Non-polar covalent bonds. Then you have polar covalent bonds. And then you have dative bonds. Okay. So today we will mainly discuss on the covalent bonds topic. Secondary bonds, there are 5 secondary bonds. Okay. 5 secondary bonds. 1, 2, 3, 4, 5. Now you should remember these all. Okay. Now when you break this whole topic into few subtopics, it's easy for you to remember. Okay. So that's what we do here. Secondary bonds. Now for today we'll just have a brief idea about this and just write this down. You don't have to think deeply about this because I'll explain this later in further videos. Okay. The dipole-dipole interactions. Dipole interactions. Next we have dipole-induced dipole interactions. Next we have ion dipole interactions. Then we have ion induced dipole interactions. Then we have London forces. Okay, London forces. So take this down. Take this down. Okay, students, now we will discuss about covalent bonds. Okay. Okay, what is this covalent bond? Covalent bonds are a type of bond that is formed by sharing electrons between 2 atoms. Covalent bond is a type of bond formed by sharing an electron between 2 atoms, a pair of electrons between 2 atoms. Okay. Covalent bonds. The topic is covalent bonds. Okay. So covalent bond is a bond is formed by sharing a pair of electrons between 2 atoms. Okay. Now, to share an electron between 2 atoms, what are the requirements? Let's say now, how can an atom share an electron with another atom? It cannot happen spontaneously. It cannot happen like automatically, right? So, in order for an atom to share an electron with another atom, from the first unit, their valence electron clouds has to come together. Okay, the valence electron cloud of an atom A has to overlap with the valence electron cloud of atom B. Okay. Valence orbital means the outermost energy level of an atom. Okay, valence orbital. This is a valence orbital. So valence orbital means the outermost energy shell of an atom. Okay. So this is the electron of A. This is the electron of B. Okay. This is how we denote in O levels now. So in A levels we denote like this. is the electron from A shared by A. This is the electron shared from B. So in order to form a covalent bond, the valence orbitals of two atoms should overlap. Okay, should overlap. Okay, now for this overlap to occur, there are some requirements. There are some requirements. So that's if those requirements are fulfilled, these atoms will form covalent bonds. Okay. There are some requirements that these atoms should fulfill in order to form a covalent bond. Okay. The first requirement is the orbitals should belong to different atoms. The orbitals should belong to different atoms. What does that mean? Let's say this is a hydrogen atom. Okay, a hydrogen atom. This should overlap with the orbital of another hydrogen atom. Not the same atom, like it doesn't happen in this case, but the orbital should belong to different atoms. Okay. Now if I take another example and explain, then you will confuse yourself. Just remember, the orbitals should belong to different atoms. That's what I told it at the beginning. Two different atoms only form a bond. Okay. The second requirement is now the second requirement is the orbitals must be suitable to overlap. The orbitals must be suitable to overlap. Let's say this is an orbital of atom A. This is the orbital of atom B. Okay. For this, I'll take a few examples. Sharing of electrons. The orbitals must be suitable to overlap. How? What does that mean? Okay. Let's say there is one electron here and there is one electron in the valence orbital of B. Now, is this suitable to overlap? Is this suitable to form a covalent bond? To form a covalent bond, there must be a pair of electrons. There must be a pair of electrons shared between both the atoms. Okay. If these two overlap, there's a pair of electrons. This is suitable to overlap. Let's say both the electrons are donated from A and there is no electrons on B valence shell, but these two overlap. After overlapping, the number of electrons shared between both the orbitals is 2. The number of electrons shared between both the orbitals is 2. Therefore, it is also suitable to overlap. This is also suitable to overlap. Okay. Let's take another example here. Here there are 2 electrons, here there is 1 electron. After overlapping, there will be 3 electrons. So this is not suitable to overlap. This is not suitable to overlap. Okay. This is not suitable to overlap. Let's say there is only 1 electron here and there is no electrons on B. Again, it's still not suitable to overlap. Okay. So basically the second point means this one, the orbitals must be suitable to overlap. So what you have to do is, under this second point of the tube, you should draw these things what I drew. Okay, you can rewind the video and draw the orbitals, how the electrons are arranged on those orbitals, and fill that space. Okay. The third point that it should fulfill is the atoms, the orbitals must physically come closer. Okay, the orbitals must physically come closer. දුර ඉඳලා කොහොමද overlap වෙන්නේ? When they are far from each other, how can they overlap? No. So physically they must come closer to each other. The fourth point now. Now when these two orbitals comes closer to each other, I'll draw it here. When these two orbitals come closer to each other, this is the nucleus of these two orbitals. Okay, there is nucleus between these two orbitals. Now we know that nucleus is positively charged. So this positively charged nucleus and this positively charged nucleus will repel each other. Okay. And this is the electron cloud. This is the electron cloud of the valence orbital of atom B. This is the electron cloud of the valence orbital of atom A. So from this positive nucleus, we know that electron is negatively charged. There is an attraction. Towards this nucleus. From the electron cloud of A, there's an attraction towards the nucleus of B. So what's this fourth point? Fourth point is the net attraction forces must overcome the net repulsion forces. The net attraction forces must overcome the net repulsion forces so that it overlaps. Okay, the net attraction forces. Now you should write with me. Net attraction forces must overcome the net repulsion forces. Okay, net attraction forces must overcome the net repulsion forces. So you can write this down. Okay, now the next topic we are going to discuss is types of overlapping. Now we know that two orbitals will overlap. Now in this place we are going to discuss how it overlaps. Okay, the types of overlapping. Okay. So Lamai, I'll divide this topic into two subtopics. The first one is linear overlapping. Second one is lateral overlapping. Okay. Now this topic you should have a clear idea. Okay, so if you don't have a clear idea on this topic, you cannot move further. The ones that you will learn in future, you will have you will not have a clear idea if you don't have a clear idea here. So please pay attention to this topic. Types of overlapping. Linear overlapping. Okay, I'll erase this for now because I want to discuss linear overlapping first. Linear overlapping. Okay, now let's say there are two s orbitals like this. This is the nucleus. There is one s orbital and one p orbital. one s orbital and two p orbitals like this. Okay. So now after overlapping, after two orbitals are overlapped, their common area is called electron density higher area. Electron density higher area. Okay, these are electron density higher areas. So Lamai, how to decide this is a linear overlapping? You draw a line between the two nucleus. Now you call this internuclear line. Internuclear line. Okay. Again you draw here an internuclear line. Here another internuclear line. So how do we decide this is a linear overlapping? Now this topic you have to carefully listen. How do we decide this is a linear overlapping? This electron density higher area must lie on the internuclear line. The electron density higher area must lie on the internuclear line. Okay. And electron density higher area must lie on the internuclear line, and the internuclear line electron density high area must lie on the internuclear line. Okay, or we can say in the other way as given in the table, internuclear line lies on the electron density higher area. Okay, internuclear line lies on the electron density higher area, and the electron density higher area must be in between the two nuclei. So basically, how do we decide whether it is a linear overlapping? The internuclear line must lie on the electron density higher area. Okay, internuclear line lies on the electron density higher area. Internuclear line lies on the electron density higher area. Okay. So this linearly overlapped covalent bond is given a name. Linearly overlapped covalent bond is given a name. It is called a sigma bond. Okay, now sigma bond. Then ඉස්සල්ලා කිව්වා මේ types of bond, ඊට පස්සේ primary secondary, ඊට පස්සේ covalent, ionic, metallic, then sigma. Okay, no need to this one. Okay, based on overlapping, we give them a name called sigma bond. Just remember the name for now. Next I will discuss about lateral overlapping. Lateral overlapping. Okay, lateral overlapping. So Lamai, let's take two p orbitals like this. Two p orbitals. So I draw the internuclear line. And this is the electron density higher area. So how do we decide it whether it is a lateral overlapping? The electron density higher area will be on either side of the internuclear line. The electron density higher area will be on the either side of the internuclear line. So before internuclear line lies on the electron density higher area. Electron density higher area lies on the internuclear line. Here, electron density higher area lies on either side of the internuclear line. Okay. So this is called lateral overlapping. And for lateral overlapped orbitals, the covalent bonds formed by laterally overlap, we give a name called pi bonds. Pi bonds. Pi bonds. Okay. Write this down. Linear overlapping and lateral overlapping. Pi bonds. It's given in the cute as well. Okay. Let's move on to the next thing. You can pause the video and write it down if you want. Okay, now we know that linearly overlapped orbitals and laterally how overlapping occurs. Okay, now let's revise. For covalent bond to occur, valence orbitals must overlap. Okay, for covalent bonds to form, orbitals must overlap. There are two types of overlapping: linear overlapping and lateral overlapping. So lamai, I want you to, now for linearly overlapped covalent bonds we give a name sigma bond. For laterally overlapped covalent bonds we give a name pi bonds. Now lamai, in exam, now this is what we want to focus on. On exam they will question you which bond is strong, sigma bond or pi bond. Next topic lamai, comparison. Comparison of sigma, this is the sigma sign, and pi bonds. Okay, you can write it in words or like this. On exam, on exam you have to write the words. Okay, you are writing words sigma bond. Here pi bonds. Okay. Okay. Now I'll take two examples. Okay, right? Now, logically, which bond is stronger? Logically, which bond is stronger? This or this? Of course, sigma bonds are stronger. Sigma bonds are strong. Why? Because here the two nuclei, okay, let's focus on this one. The nuclei of this atom is attracted to the electron cloud. Okay, is attracted by the electron cloud, is attracted by the nuclei. On this side also the electron cloud is attracted by the nuclei, therefore it is strong. Here both the nuclei are closer to each other. If two positive charges are closer to each other, it's easy to break, right? It's easy to repair one another. So if this is easy to break and this is more strong, so if they ask to compare the strength of sigma bond and pi bond by giving reasons, what you have to say is, as given in the cute, sigma bonded orbitals. Okay, you have to write it down. Sigma bonded orbitals contain nuclei attracted to the electron density higher area. Sigma bonded orbitals have nuclei attracted to the electron density higher area. But pi bonded orbitals contain two nuclei closer to each other. Therefore, sigma bonds are stronger than pi bonds. Okay. Therefore, sigma bonds are stronger than pi bonds. Okay, now I want you to draw a table. Now I have given a space on the tube on comparison of linear and lateral overlapping. So I want you to write these points down. So there's a table like this. Here it is linear, it is lateral. Linear overlapping, draw an example like this. Lateral overlapping, draw this example. And start to write these points which I am going to say now. Write these points. Okay. Because you have to write if they ask on SAQs to write, or you just have a brief idea about this. Okay. Here, first point, linear. Electron density highest area is present in between two nuclei. Electron density highest area is present in between two nuclei. On lateral, electron density highest area are present in either sides of the nuclei. Electron density highest area are present on the either side of the nuclei. Second point on linear is internuclear line lies on the electron density highest area. Internuclear line lies on the electron density highest area. The second point on lateral is electron density highest area are present in either sides of the internuclear line. Electron density highest areas are present on either sides of the internuclear line. Third point on linear one is forms a sigma bond, forms a pi bond. Forms a sigma bond, forms a pi bond. Fourth point is there are no internuclear repulsions. There are internuclear repulsions. On linear overlapping, there are internuclear repulsions. There are no internuclear repulsions. On lateral overlapping, there are internuclear repulsions. On linear overlapping, the fifth point is bond is strong. Here, fifth point is bond is weak. Bond is weak. Sixth point is SSSPPP orbitals can form sigma bonds. The sixth point here is only PP orbitals can form pi bonds. Because this cannot overlap laterally. S orbitals cannot overlap laterally, only p orbitals can overlap laterally. Okay, write these points down and let's move on to the next topic. Let's move on to the next topic. Okay. Now this is the topic that will question you from the exams. Okay, this is the topic that will question you from the exams. Determination of number of sigma bonds and pi bonds. So I'll teach you a easy method. Lama, if there is a single bond, listen carefully, I'll teach you a simple trick. They will ask you to determine what type of bond is this. So you should tell whether it is a sigma bond or pi bond. How to do that? If there is a single bond, it is always a sigma bond. If there is a single bond, it is always a sigma bond. If there are two bonds, one of that bond is a sigma bond and one of that bond is a pi bond. If there is a triple bond, one of that bond is a sigma bond and two of them are pi bonds. So the simple trick is what? The first bond that an atom forms is sigma and the rest of the bonds it forms is pi. Between two atoms, okay? Between two atoms. let's say hydrogen. How many number of sigma bonds and pi bonds? Sigma bonds 1, pi bonds 0. Oxygen. Sigma bonds 1, sigma bond will always be 1 and pi bond equals to 1. Nitrogen, sigma bond equals to 1, pi bond equals to 2. So in exam structured essay question and MCQs, they will ask you determine the number of sigma bonds and pi bonds. And what you should do is, if there is one bond between two atoms, it is a sigma bond. There is two bonds, one is sigma, one is pi. If there are three bonds, one is sigma, two is pi. Okay, so let's discuss some questions so that you can, it's easy for you to determine the number of sigma bonds and pi bonds. Let's discuss some questions. Okay. Sorry. Okay, now the first question. I'm not sure whether it's clear for you all. So I'll just draw it here, over here. First question. H, N, H, C, O, N, H, H. Number of sigma bonds and number of pi bonds in this molecule. So how to determine that? Number of sigma bonds, if there is one bond between two atoms, it is a sigma bond. How many sigma bonds are here? 1, 2, 3, 4, 5, 6, 7. How many pi bonds are here? 1. Here there will be one sigma bond and one pi bond. If there is a single bond, then it is sigma. Sigma, 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 sigma. Here there is a sigma bond and a pi bond. Okay. So the second question is, so you write this molecule first, pause the video and then look at the answers. Pause the video, try to think and then look at the answers. Okay. Then the next one is, there are 3 bonds here, 3 bonds. Okay. How many sigma bonds? How many sigma bonds? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. How many pi bonds? 1, 2. So I told you, when there is a double bond, the first bond is sigma, second bond is pi. When there is a triple bond, first bond is sigma, the other ones are pi. So how many sigma bonds? 1, 2, 3, 4, 5, 6. How many pi bonds? 2. Okay. The third example. H, N, H, C, H, H, C, O, O, H. So how many sigma bonds am I? 1. How many sigma bonds? 1, 2, 3, 4, 5, 6, 7, 8, 9. How many pi bonds? 1. Fourth example. H, C, triple bond C, C, H, H, C, H, C, H, C, O, H. How many sigma bonds am I? 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 sigma bonds. How many pi bonds? 1, 2, 1, 2, 3, 4. 1, 2, 3, and 4. Okay. 4 pi bonds. By the end of this video, okay. So we have come to the end of this video. By now, you must know. Okay, let's recap. Let's do a small recap. Okay, Lamai, by now you must know what are the types of, now, what is meant by a bond? What is meant by a bond? Then bonds are divided into two topics: primary bonds, secondary bonds. Primary bonds, there are three types: covalent, ionic, metallic. Covalent, there are three subtopics: non-polar covalent, polar covalent, and dative bonds. Secondary interactions, there are secondary bonds. For the bonds we give another name, interactions. So secondary bonds, there are five types. There are five types: dative bonds, dipole bonds. Okay, dipole bonds, dipole induced dipole interactions, ion dipole interactions, ion induced dipole interactions, and London forces. Secondary bonds, we will discuss about it later. Then covalent bonds. For covalent bonds to occur, we know that orbitals have to overlap. Then we discussed about the types of overlappings. Then we know the names given for those bonds, sigma bonds and pi bonds. We compare the strength of those bonds, who is more stronger. So then we know how to determine the number of sigma bonds and number of pi bonds. Okay students, thank you for watching this video. I hope you understood this lesson.